This is about 3D printing, and I am up first, so I'm going to be talking about Shapeways, their website, and some of the products they carry. I've been using Shapeways for the last 2 years, since the last GSL, and the website needs a little work. It's good, don't get me wrong, it's a great website, and there's definitely a lot of stuff on there that you just absolutely cannot get anywhere else. I bought a lot of motor parts from it, a lot of LS motor parts. I'm a big Corvette guy, so anything General Motors kind of catches me. I bought some heavy truck components too, and just some general hot rod parts off of them. What do they call that? The Frosted Ultra Detail is amazing stuff for detail. It looks really, really good, but it is like insanely brittle. It will just break on you if you look at it weird. All the stuff I bought from them seems to paint up really well. I've done it with both my own paint, just super primer, and then whatever over the top of that. It seems to work really well. I've also used testers right out of the bottle, just, you know how everybody does that right over the bare part. That seems to work pretty good too. So it's good product, and you know, it's easy to use, and they're definitely really, really nicely executed. One thing to look out for is a lot of stuff on there is just what somebody has designed and they want to stick on there, and that's what you get. So sometimes the quality of the parts varies, but everything I've seen off of there seems to be pretty top notch. Yeah, like I said, I've been using it for 2 years and can't really complain. If you are going to get on the website, one tip is look up what you want. Like I always look up 1/24 scale wheels. I don't know why. For me, that's where I find most of my car parts. But you'll find somebody who has something you might be interested in. Get on their shop, because a lot of times the stuff that they have for sale, it won't just show up in the search. So that's just a little trick on using their website. Anybody have any questions? Oh, come on, I've only been up here like 2 minutes. I know I didn't cover anything with that.
They're all Shapeways addicts.
Oh, is that it? Everybody here's already been on Shapeways, and you're just like, why is this guy telling me stuff I already know?
Do they carry prices on parts and stuff like that, headers and stuff like that?
Yeah, they do. Oh, yeah, okay. So on there I've seen wheels, engine parts, turbos, headers,
Okay.
yeah, carburetors. There's, yeah, I've seen some bodies. Yeah, TDR's on there.
TDR stuff, so I bought some of their stuff. That's pretty good.
Yeah,
25th scale.
Yeah.
They're beautifully
What
done.
turbos at the NLEs
Yeah.
last Saturday?
Oh,
Because
They're
I
so
noticed,
small and they're perfect.
I noticed
Yeah.
a lot of these kids out there and stuff, the headers for Chrysler, there is none.
Yeah, exactly.
Unless you're pro mod and stuff like that.
Because Mopars are crap.
Yeah, but-
Well, I'm a Chevy guy, and I'd be like, hey,
No,
what do you see with that?
Let's not get political.
Trying to get out of the way.
This is a common thing.
He knows I love Mopars.
The Mopar stuff is limited on Shapeway.
Yeah, it is a
I
little
kind of
bit,
slant
yeah.
that way, and it's.
Yeah. Yeah,
You can always contact the designers, the guys with the shops, and tell them what you're after.
yeah.
There's a place that I go to, it's a 3D,
3D Content Central?
yeah. And they have a whole, they have a lot of stuff.
Uh-huh.
And you can get on there, they got like shocks and A-arms and just everything.
Yeah.
You could, I'm pretty sure if you're willing to dole out the money, you could build an entire kit off of that website.
I believe it, I believe it.
And shipping on it's relatively inexpensive, and they're, for what it is, it's pretty quick. You'll do the car, you'll pay and everything, and then it'll pop up and say, hey, thanks for your order. And usually within a day or two, it'll pop up and say we're producing it, and then usually about a week or so, they'll ship it to you. You'll get it 4 or 5 days later. So
Okay.
there's a tiny bit of a lead time to it, but that's
Yeah.
about it. Yeah, overall, I love them. I just wish they made their search a little bit easier to do.
They have refined their page recently.
Yes, they have. That's actually, yeah, they just did it. It's getting a lot better to find. They're allowing the guys to post tags on them, so if you do find the part you want, just scroll down to the bottom. It'll say like 1/24th or 1/25th on it. Click on that. It'll definitely narrow everything down to your scale.
And
Sorry, what's that?
there's one site that has a list of scales on the left side, and you can pick your scale, and it'll come up all the parts that that particular shop offers. So you you can search within a shop by scale.
Yeah. And that was the other thing I was gonna say, I keep saying 24th, 25th, that's what I build. I've seen 72nd, HO scales huge on there, all of your railroad scales. Got quarter scale, 6 scale, 35th, 48,
He had
72nd.
1/43 scale Chevy blown
Yeah.
motor the other day. It was like, really
That was
nice.
TDR.
And I'm pretty sure a lot of guys here do the Matchbox cars, the small 64 scale diecast stuff, because they have 1,000 things on there for those. You'll find a lot of stuff for that on there too. So yeah, it's a really good resource for modelers. I mean, 3D parts are pretty much resin in use, so it's a good way to go. And then, like I said, you can always contact these guys and they'll start throwing other stuff together for you. I got a friend of mine who does resin casting and he's working with a guy, and that guy will just print whatever he wants and then he resin casts it and sends it over. So it's good. It's good. Shapeways is good.
I'm gonna do the bio for.
Oh, yeah, okay, and then next up, I'm gonna have Chris Sobak, who I know from here, but I'm gonna have to read his bio out of the book.
I'll give a little bit.
Oh, Pay crew of a top alcohol dragster?
I grew up around, yeah.
Awesome, man, I like that. And then you do Chris Sobak Design, so you do design work and stuff with them, don't you? With the 3D
It's
stuff?
a little model thing that I just kind of do, but the part of it, I'm actually I work in the aerospace industry. I'll give a little bit of a background
Oh, okay.
when I get out there.
All right, perfect, well, Chris is up next, so Chris Sobak.
All right, guys. For those of you that don't know me, my name's Chris Sobak. Is this not working?
It should be. Is there a power button on that?
On the side.
After the battery turn.
Oh, there we go.
There you go.
So a little bit, what I want to sit here and talk about to you guys. I'll give you a little background about myself. I want to go through and I'm going to be pretty much talking a little bit about just the basics of 3D modeling, some of the stuff, how it goes. I want to give you a basic concept of the sketching, some of the terminology of SolidWorks, and kind of the differences between parts and assemblies. And I'm going to walk through one of the parts that I've done for my funny cars so that you can kind of see what it takes to make a 3D model, because it's just something that's just not one step. And then I'll go through some examples of parts that I've drawn, and then how to actually send the file, save it out so you can upload it to Shapeways or any other 3D printing service. And then I'd like to show you a little bit of how I prep mine, and we can, if you have questions, feel free to ask. So a little bit about myself. I started building models as a young kid, and I really got into it when I was about 15 years old, and started doing that until I kind of went to college, kind of had a hiatus and stopped building for quite a while. And then probably about the past 7 years, I really got back into the industry, or into the hobby building, and been building since. A little bit of my background: I went to school for mechanical engineering. I got a bachelor's degree, and from there I've worked in a few different aerospace companies. I started out with a material handling company doing AutoCAD, which is a two-dimensional drawing. And then when I went to my first aerospace company, I started using Pro-E. Pro-E is one of the other, at the time, that's what our school taught us. And it was a really good CAD system, and so got my feet wet with that. And that was from about 2004. Did I just do something? I'm sorry.
Hit the other way. There you go.
The company I was working for, we ended up switching to SolidWorks in 2017. Reason being seat cost. At the time, Pro-E was probably about $50,000 a seat, and SolidWorks we found was much cheaper. And so with a lot of that, the part that I actually enjoy is seeing something from I don't know how to run this thing.
Someone else got hold of it.
I'm sorry. Yeah, darn engineers. And I kind of lost my train of thought. But I found in my career that I actually enjoyed seeing stuff where you start something with going from paper to CAD work to a finished product and seeing it kind of being done. So that's a little bit about myself. So what is SolidWorks? SolidWorks, it's a mechanical design software that's feature-based and parametric solid modeling tool. And so feature-based is basically, let's see if I can run this thing without turning anything. So feature-based, it's a model that's made up of individual elements. And the parametric is the dimensions and relations are used to create are stored actually in the model. So any sort of dimensional on 3D model, when you go to a drawing, which is years ago called blueprints, I'm sure many of you remember the blueprints. And it'll take all your dimensions and it'll be able to, if you change something in the model, it'll update it in the drawing. But most of the stuff for what I'm doing, or if you're gonna do any type of 3D printing, you don't need to have a drawing submit to Shapeways or anything like that. Now, solid modeling is a solid model that's the most complete of the geometric models in the CAD systems. So now here kind of some of the basics of sketching. 2D sketching is the basis of modeling in SolidWorks. And sketches are an actual collection of 2D geometry that is used to create the solid features. And from that, you get the sketch geometry. You know, the types of two-dimensional sketch geometry are lines, circles, arcs. It's actually creating whatever kind of little sketch that you're trying to do. Yes, sir?
Is it vector-based?
Some of them, yeah, you're getting stuff that's in the coordinates where you got your X, Y, Z, and I'll show you some examples of a screenshot of what stuff and how you draw on the different planes and stuff, but yeah, there is stuff that's vector-based on some extent of things. Okay, so within sketching, you've got stuff that's called sketch relations, and you want to have your lines, or it's basically relations restrict the movement of the entities, and examples of those are keeping something that maybe you draw a line, you draw this line that's 45 degrees, but hey, I want it to be horizontal, I want it to be vertical. And you're going to have stuff that's collinear, stuff can be concentric, perpendicular. You got two lines. If you got, say, a line coming down here, we don't want this line, excuse me for using my hands and I'm trying to show things, but we want it to be perpendicular. You do a couple clicks and it'll actually align it the way you want it to. Stuff can be tangent, parallel, and they're applied to the sketch geometry. So let me do. So here, and sketches are used for a lot of the different features in a part. Now, once you get, so there's other things, there's extrusions, revolve, sweeps, lofts, and what I wanted to do is I wanted to show you a little bit here. An extrusion is taking a sketch that you've drawn on a plane, and you're just extruding it out. You give it a certain dimension, and it'll say it's an inch you're coming out from wherever you're drawn. It just takes the part straight out. Now, a revolved is you're taking something, you've got a center line, and you're actually revolving the part. So a couple of these things you'll get to see in my sample part that I'm going to go through. I've got some of these things here. Now, a sweep will take a profile, and it'll actually be sweep across a path. So here's kind of like an arc. You can see kind of how it's got a radius, or it's going around this piece. And then a loft is a sketch that you can take through guide curves. And a guide curve will kind of guide the path that the sketch is going to go through. Now, some other terminologies here. Did I just know? Okay. A feature, basically any sketches, planes, bosses, and cuts are considered a feature sketched. Features are also based on sketches. Planes, they're used as the primary sketching surface for creating a boss, revolve, and cut features. And your planes are kind of like your coordinates, your X, Y, and Z in the CAD system. So an extrusion is one way to create a feature in a shape of solid. And an extrusion will extend a profile along a path normal to the profile plane for a given distance that you may give. And that's going to create like the starting of your model. Now, a boss is a term that is used to add material to your 3D model. And a cut is a term used to remove material away from the 3D model. And they all start out as a 2D sketch and remove material by extrusion or revolve. Now, SolidWorks is they base a lot of their stuff on design intent. And basically, you want to approach a model as far as you're drawing your sketch, and if you got stuff you're making a lot of changes, or you want to have it so it's easily changed. So let's say I draw a box that's 6 by 6, I extruded a foot. Well, I add all these other features to it, and you want to go change something. You realize, hey, I made a mistake on something. You can roll the model back, and it'll actually change one dimension. Everything still stays where it's at. But if you don't put some of the stuff in the correct order, it may actually move some of your holes or whatever you have, so you got to actually fix more of the model. Let's see here.
That's all dependent on how you dimension it.
Yeah, no, that's true, yeah, thanks. Depending on how you dimension it and how you set up your part that you're building, kind of drives a little bit of what the end result. And if you don't do it in some specific orders, it may actually, I've had some stuff that it blows up and you got to go back and fix it and say, okay, let me redo this in a way that I know it's going to work. So also in SolidWorks, they got parts and assemblies, and there's a difference between the two. The part is an individual component that's made up of sketches and features. And so that'll be like, let's just say this is one piece here that's a part. Now, an assembly is made up of parts, which can be also called components, that are oriented and positioned in the assembly using mates. So the mates will relate faces and edges of the components so that you can, put them together or to some of the planes. So if I had this part and I want to, let's say, mate it to this microphone, you're going to sit here and you can say, hey, I want to take this edge, I want to mate it with this, so it'll make it coincident. And then it's got movement here, and it's still got movement here. So you can take some of this, let's say a center plane, and align them and get everything so that it's basically kind of stuck in its position in the assembly. So right now, I'd like to go through a little bit of a sample part that I've done for my funny car. And what I'm going to show you is I'm going to go through a Hillborn fuel pump. And basically, here I'm trying to replicate some stuff that no kit has this style of pump that I've seen. And one of the things I like to do as far as starting out with my 3D models, if I can find any one-to-one dimensions, I like to start out using one-to-one because I can scale everything down once it's said and done. So I actually contacted Hillborn, and they had no CAD data for me, but they were able to take apart. They gave me 3 pictures. They placed it on a piece of paper, gave me some dimensions, and let me go to the next one. Oops. And maybe the next slide that I'll show you once I get into it. And so I'll take and I'll interpolate some of the dimensions. I'll take my calipers. Let's say you've got a distance, known, okay, this is 6 inches. I measure with my calipers. And so I know if it's 2 inches, and I go through the math and I interpolate everything. So I actually literally will draw points on a sketch or on a printed out paper. And then I can get all my dimensions based off of a couple known dimensions. So here is kind of what the software looks like in SolidWorks. So they've got what's over here. There's a feature tree, and as you actually start building stuff, this side here will expand and grow with all the different features. It could have multiple features as far as like extrudes, revolves, circles, hole wizards. Now hole wizard's got something that you can actually throw in. It's like threaded holes, specific drill hole sizes. And over here, here's your sketch planes. So SolidWorks is calling stuff. They've got, I believe this is the right top, or this may be the right front top, but they're also still, it's an X, Y, and Z coordinates. And so here's the information that Hillborn actually sent me. So they sent some stuff showing, you can see a couple of these dimensions here. So I took all 3 of these drawings, and I did what as I mentioned, to go through and interpolate the rest of the stuff, or the rest of the dimensions I'm looking for. Sorry about that, guys. So here, this is the Hillborn fuel pump that I modeled. I'm just showing a quick, here's the assembly view, and I just wanted to show the exploded view as far as I broke it down into 3 components, kind of the base, the main assembly, and a cover cap. So this is gonna be the steps I'm gonna go through to show you as far as right now with the base part. And so here we've got, so I started this sketch out. Let me go on this side just to be a little easier. So I started this sketch out here on one of the planes, and you can see I've got a center line that comes here. Now there's my XYZ zeros here, and you can see the path that everything I've drawn here. And once I'm done with that sketch, I actually went through and used the revolved feature, and it took that sketch here, and you can kind of see what's in yellow. It's actually wrapping this around, so here's the end result of what you get on that first portion of building this base. And then second here, I went through, and now I'm adding an extrusion. So I have a circle here with a given diameter, and I came out and extruded that piece out. So I'm building this step by step how I'm building this. And then you can see here, it's kind of a little bit blurry, but there's the first feature, the second. Now stuff that you're seeing here is just in a rollback stage. So I was able to get my images and stuff for these.
So when you're extruding, you actually tell a program how much you want that to extrude out
Yeah.
from the plane.
Yep, exactly. Whatever it could be. I can extrude it from 1/1000th of an inch. I can extrude it 1/10ths of an inch. I can extrude it 12 feet. Yeah, you let them know how far it goes, and it'll go as far as you want it to go. So then here, the next thing I was doing was going through, adding some of my mount holes. And so I used a feature called, and this one I believe I used what's called a hole wizard. And a hole wizard is a feature that you can actually pull different sizes automatically from SolidWorks. You can do stuff from dowel pin holes, you can do threaded holes, screw clearance holes. Just turn that off. And you guys can, okay. Threaded holes, dowel pin holes, screw holes, or screw clearances, and it gives you, let's say you got a 1/4 inch bolt, it knows a given, or actually if it's, let me go back to use a 1032, because I know it's like, the OD is like 196, and typically a clearance hole for a 1032 bolt is 201. So it'll give some normal clearances. You can do some stuff where you hold a close tolerance, loose, or just normal. And sometimes you may want something that's not so tight, I guess, as far as, hey, I just need something, I'm mounting a plate on something, and it'll allow the screw just to drop right in if you don't have everything lined up properly. So, but you can also do this thing. I could have done this by drawing 3 circles and doing it, giving each hole dimensions, and then you're creating the piece here. So you got the mounting holes. And I think I did a couple things where I didn't want to show 100% every step because I don't want to bore you guys too much with maybe too much stuff I've seen. See Jim over there yawning at me. So then next you can do some other features as far as like adding fillets and chamfers. This here I'm adding fillets. So a fillet is taking a sharp corner and you're given some radius in there, and a chamfer is you're breaking an edge, so you can do something if you want, like let's say a 50,000th chamfer at a 45-degree angle. You can do them as far as 30-degree, whatever angle you need something to be. So that kind of adds a little bit of a little hard to see here because it's fuzzy, but it's just a little rounded feature, so it's it blends into the part. And then I did the same thing here for the outer portion of the base. And then you can see here, it's got that guy on that. And I don't remember, okay. So since I took this part and it was drawn with the 1-to-1 dimensions that I interpolated, I came back and SolidWorks has a feature that you can scale the parts. So you come in and you select what you want to scale, and So since this is 16 scale, I just typed in 0.0625. It scales it. Now, if I want 25th scale, I could put 1/25. It'll do the math, or I could calculate that myself. It'll scale it to that. I could upscale it, you know. So it's kind of nice to be able to take something from 1 to 1 and put it into whatever scale that's needed.
Should you always start in one scale then?
I like to, if I have the dimensions, I like to start out that way. You don't have to. I've done some other parts that I don't have the dimensions, so I may have taken a kit part and started just measuring that and started out and then just left it at that and just said, okay, here's what I know and stuff that from whatever kit that I'm using. And, you know, it still works out. See, because you definitely want to make sure that the parts are going to line up correctly. And, you know, if I don't have that information, I won't actually use it. So here now is the main body of the part. Another sketch, as far as you can see, this sketch is a little more complex. So I started out, if you see this little dash line, you can do stuff what's called kind of a center line. And I'm basing everything around kind of the X, Y, Z, 0 here. Draw my circle, given my different distances, get my shape that I want, adding, you know, here's a diameter. This is either, I must have done this as a radius. And then offsetting, or, you know, I got a given distance from the center down to here, and then how far out this dimension is, my overall dimension, and my width here. And so I guess I didn't show when I extruded this part, so you can kind of see the thickness here. Then this guy, and I'm kind of jumping a couple steps at a time with this because I have a center plane going up and down on this guy. Got this diameter here, and I extruded one side, and I repeated that, and I did another sketch that went that way. And I think, thinking about it now, I could have actually drawn a center, and I could have extruded it both ways, so it would go both sides automatically in one step. But if you needed to have one, say this guy had to be a ½ an inch, and this one's got to be an inch, you could break it into 2 steps and have them extruded out a different just given distance. So the next step on here is I was adding a fillet here. So I did the fillet feature, gave whatever radius I wanted, grabbed this edge and this edge, and it creates this. And when you hit the little check over here, and you can see it creates your fillet here. You could have done another, I'll go off, I don't want to say off topic on it, but I could have drawn in this same feature here, and I could have cut that away versus doing the fillet feature. So I don't think there's no wrong way that you can draw something. Sometimes it may be, you may take a few more steps, or sometimes you try to do it in the least amount of steps as possible. Paul?
When you're extruding something, is it better to put a video into it, or do it individually?
You know, I think it's a personal preference. Sometimes I'll try to put as much as I can in there, but then sometimes I may start something basic and then I'll add cuts, and depends on how else I'm going to add some other things later on. But I think a lot of times I try to draw as much in there as possible if I can. I don't know if this, no. I was just thinking if this had some other like radiuses or chamfers, you can add those into a sketch too, as far as depending on what you're wanting. Say, trying to think on the fly here. Say if there was some, if we weren't doing this rounded piece and you wanted corners that were 45 degrees cut here, that may have been a way to do that in that initial sketch, and it'll just save an additional steps down the road. I don't know, hopefully that answered that question. So now after a few more steps here, I've gone through and I've actually added some different mounting holes, some more fillets, and then same thing, same process that I did in the last component. It was drawn in 1:1, and I scaled it down to 1/16 scale. So here they've got where you actually would come in and write what you want to scale it to, hit your check mark, and then it will automatically size it down. And oh, that's just, I guess, showing after it's been scaled down. And over here, so you can see on this feature tree, sorry guys. you can see these little steps. So there's each one of these guys here is one feature that's building this part. So it's taken, you know, all these different features, and then you're ultimately getting your 3D model from there. And now here's the cap part that goes on the fuel pump. And so I've started out with drawing, you know, a circle on a plane, and now I'm just extruding it. And so here it's kind of showing you before you hit the check mark of the extrude. It's kind of, it'll give this, and you can, like I said, you can change whatever distance that you're going here, and then here's what basically this is a disc that it starts out as. And then I'm adding another sketch and creating a boss feature, which is another just extrude of a circle. And I believe I've offset, there was a specific distance why I wanted it from the edge over, and I think it was because of how I was measuring the stuff off those pictures. Now here it is after it's been extruded, so you can see this little boss feature that's been added to this disc. And then going through adding, there's a hole here that comes back, and it doesn't go all the way through the part. And so I skipped a few steps ahead and just added the rest of those mounting holes. I didn't think you guys want to probably keep seeing me go through some of the same stuff. And so here, basically, once it's said and done, these guys were mated. So with this assembly, I started out by basically bringing this part in, and from its origin, which is the X0, Y0, Z0, place it on the part. And then the way that I mated this, so this feature here, I took this boss feature, this circle, this face, and on the back side of this part, if you can see this little recess cut, there's an ID there. So I'd grab onto the ID on this, onto that, and make it concentric, so it lined them up. And then the next step is the face that's on the back side. I could use this face and line it up to here. It'll mate them. I can mate them together. I can mate them by giving a distance. I can say, hey, I want this 5 inches away, and it'll put it 5 inches away. And with doing the concentric here, it'll actually, the part can spin, so you can do one of two things. You can either take, and there's a feature that you actually lock it. So you can, there's a command, you right click and you can lock the component, or you can take and align one of the planes from here to a plane in here, just so everything's, it's what's called being fixed, and you want a fully defined model. You know, you can leave stuff undefined, but it's better to keep everything defined, or keep it fully defined. So I did that for both of these pieces here, and so that's kind of what you see over on this.
Question for you, Chris.
Go ahead.
When you're doing that, does the software allow you to, is there an automated process for doing your fits between parts?
No, that's your...
You have to manually do that?
You do that, like some stuff, I'll draw some things where, let's say like a dowel pin hole. If I draw something that I'm saying, okay, it's a 1/4 inch dowel pin hole, my other part's a 1/4 inch. Now they do have a feature in the whole wizard where you can say a press fit, a clearance fit. Now if you have that, SolidWorks, it'll go in and you can determine, and I know in one of the machinist handbooks, it's got, and it depends on some stuff, if you're wanting a real hard press fit, normally it's you're like maybe a thou and a half for a light press fit.
But it's kind of more of a manual thing, you have to know that.
Yeah, some of that too, or there's sometimes I'll take those, like that dowel pin hole, and on the drawing, I'll sit there and say, okay, here's a 250 pin or whatever it is. My part, I'll have it 250, and it's like size for press fit, or maybe I'll give them a dimension saying instead of it's 2500, and I'm going to say, hey, I'm going to size this so it's the hole that you're putting in, maybe like 2495. I want a 5/10 fit, so I'll give a limit, a plus or minus on the hole that they have to be in. It'll actually press fit in, because if you give them, let's say on a drawing, I've got typically 3 dimensions. In my work, we go plus or minus 5 thou. So if they go and they oversize it, that pin's just going to drop through.
Right.
If you want kind of, and sometimes you have to do a thermal fit too. You'll heat up the main part, and then you'll take your pin or whatever you're going to insert. You may freeze it in liquid nitrogen. It shrinks it. Yeah.
I was
Just so some other people, I don't know if everyone
Yeah,
knows
I'm
some
not
of
familiar
that.
with the software, so I don't know
Yeah.
how much of it is manual and how much of it is designed into.
You're going in and adding, you're telling them all the different tolerances you want.
Tolerances.
You can do
And then when
everything.
you scale it up, it just automatically, whether it's 16th scale or 12th scale, it fits
Yeah,
eventually.
that stuff will fit. I think on some of the parts that I've done here, I can't remember because I've been trying to figure out what's the best tolerance. I've had some pieces I may have gone 5 or 10 thou on something that's slipping in because when the parts are actually printed, it's not going to print like if you're machining a part, you're not going to have it down to, hey, this can be within 5 thou. You may have a little bit of, maybe a little bit bigger or tighter, or so sometimes I'll have to go back and sand it if it doesn't actually fit in.
Do you test paint and stuff too, or do you have the ability to?
I've got some stuff that I'll show you when I go through to how to paint the parts and a little bit of the process of what I do. But yeah, I'll touch on that in a second.
That's a good point, because I've noticed in a lot of the more modern Japanese kits, you paint things and they don't go together because the paint's too thick.
I've learned a few things that I've had some issues that I've had tolerances too tight on some stuff. You're like, okay, I got to go back and sand something so it fits a little bit better because I didn't take into consideration. Depends on how much you paint, how thick the paint is. You know, you may typically, I think it's about, let's say 2 to 5 thou thickness when paint. I guess just depending on how many coats. But some of the stuff I'm trying to do, I think that I just may end up painting. I try not to paint some of the surfaces that I'm going to make, but that doesn't always happen.
So it's probably nice to know how thick one coat is and how thick two
Yeah,
coats is.
and
how
that's
thick
hard.
3 coats is.
Yeah, that's hard to kind of do. I know that they make some stuff for the real auto body stuff that you can actually go in and you can tell the thickness as far as with a gauge, but that's got, you got a magnet and it's pulling and it knows when it pulls away. how thick it's-
Those gauges are pretty
Yeah.
big and they wouldn't.
Yeah, they wouldn't work
model
on it.
anyway.
That may not be functional for us.
About
That's
that
probably
thick.
true.
I work with powder
Do you,
coat.
print your
yeah.
own parts, do you send?
No, I use the Shapeways service. I'll touch on a little bit on how I get that in a few more slides, but I have a service. I just use Shapeways because it's kind of, to me, it's easy, it's simple. I can upload the part. I can get kind of a cost on what it's going to be right then and there. And it goes through a little analysis, and I'll show you some slides on that.
Anybody can use shape?
Yeah, anyone that has ability to, basically you just need to upload a specific file type, and I'll touch on that too. But anyone can upload their stuff or parts that you find.
The file you send to Shapeways is a
It's a-
SolidWorks file or?
No, it's
STL?
it's an STL.
Okay.
And I'll touch a little bit on what that is here in a couple slides from now. So here, I just want to show you a few of the different parts I've actually designed. So I guess I want to back up and kind of tell you a little bit about how I kind of started to do my own stuff. As far as I was buying a lot of stuff from TDR. And after seeing some of those components, I'm going, Don, I'm like, hey, I do this stuff at work. Let me see if I can draw something up and have it print. And it all was kind of driven off the blower that was on my funny card that I'm trying to replicate a Mooney hand blower. And I was taking a resin kit, trying to take the ribs out, make it look like the correct part. I wasn't happy with it. And so that started my path, I guess, down this 3D printing. And I just decided, let's see what else I can do and what is it capable of doing. So I think I've pushed some limits on some parts. Excuse me, as far as will it print. I've learned some different things from like hole sizes, as far as how small of a hole will Shapeways or the materials allow you to print. I found for me 16 thousandths is the smallest I've gotten it to print. And sometimes I'll do some holes if I know I want a specific size at the end. I may go a little bit smaller and I'll drill it out with my pin knives, just so you get a nice crisp, clean edge. So here I've drawn up, this is part of a disc brake hub with photo etch pieces. And I actually had Jim from Micro Nitro, when he was around, I actually drew up this part, sent him some drawings, and had him machine these for me. And I had actually used, I think I found on eBay some photo etch. It was some 1/16 scale photo etch parts off of a Ferrari. And I just, I was trying to figure out where am I going to find some photo etch disc brakes, and did that. And so that's kind of worked out good. I've done some, fire suppression bottle. where I've got a couple examples of these guys here with me today. But I drew up the bottle, I was trying to do up the brackets, I drew basically the valve body, the little knob, and everything else that you see there. But at the end of the day, I think even though I had 3D printed this, I had the guys at work actually machine a bottle for me, and I ended up painting the bottle. But I wanted just to make sure. And I actually made the bottle in a 2-piece because Shapeways bases their stuff off of volume of material. So the less material that you have, the cheaper the part's going to be. They typically, the materials that I'm using up here is the Frosted Ultra Detail and Frosted Extreme, where I can tell you the price on the Frosted Ultra Detail, it's $3.49 per cubic centimeter, and the Frosted Extreme is like $5.99. And they've got a $5 service charge that any part you upload, you automatically pay the $5 plus whatever the price of the material is. Yeah. Yeah, that's what the part I can show you here that I got. It's hollow inside.
And the other thing on this breed, could you scan it and then, not that scan it, use that as a starting point to do your drawings, or?
You can do that. You can actually take pictures. I've done it where you can take images and you bring them into the sketch, so you can have a known part. Say you're trying to get. Sorry about that. Say you're trying to get this little edge here. That's the star pattern. As you're saying, you can scan a picture or bring just a picture that's a straight-on shot. It would be in your plane, and you can actually physically draw that, and then you can go in and dimension, and then you can kind of scale that from getting that basic shape. So SolidWorks has that capability to do that. So here's a couple other parts. I got some jack ramps, and I've had this idea of how I kind of want to display the funny car. I want it a little bit up off the ground so I can put a mirror so you can see underneath it. Well, this was a jack ramp that I grew up changing oil in my El Camino on. It was in my dad's garage, and measured it when I went back home one day, and let me see if I can print this thing. So I drew it up, rescaled, and I've actually got a couple of those guys over here I can show you. I've taken, this was one of the Mallory ignition boxes, and like I said, I'm trying to replicate as much as I can on this funny car with limited amount of pictures that I have. So you can see here, I've drawn this up in 3 separate pieces. Now, most of the hardware you see here was Scale Hardware stuff, and probably as many as you know, Scale Hardware has kind of gone away. But there's a gentleman, and I think his name is Marvin. He's out of Florida. I'll have to find out a little bit more of it. But he carries a lot of hardware for.
They're back, and there's somebody else
Well,
who's
no.
bought that line.
This is this Marvin guy, and it's I think he's carried a lot of stuff for Posher, some 8-scale stuff, but he's picking up all of Bob's line from Scale Hardware. So if many of you Scale motor cars. So that's kind of it's a nice knowing that we have that other company back if you like to use some of the hardware. So here's another thing that's kind of my Jolly Rancher Stagecoach chassis that I've drawn up. I've actually got this down on the display table, and you can see I started out with just taking an image of, it was a side view of the car doing his wheel stand, and I knew that the car was a 119-inch wheelbase, so I basically took and measured from center wheel to center of the wheel. And I wish I would have actually put this in here now, but I didn't think about it. And I took a lot of dimensions, and just to kind of get a rough idea of what I was doing as far as how to try to figure out how to scale everything, or how I want to draw it up. And so just wanted to show you a little bit of the stuff there that I've done on that. Now here is a lot of components that is on my funny car. So everything, as I mentioned earlier, I started out with doing the blower. Now this blower's drawn in 4 pieces. So you got the main body, you got the back bearing housing, there's a spacer, and then where the front portion of the bearings go. I've drawn up, the injector hat. No one had a K-style barrel valve that I was looking for. Revell's kit, didn't look correct, so hey, I wanted to do that. I've drawn up, pulleys. I've drawn up a starter engagement bracket. I made the belt, made some fuel distribution blocks. Even, I don't know if you can see it, but I've got some of the linkages that actually go from the barrel valve to the injector hat. And I purchased some used items from a company called RBS Superchargers. They were pretty cheap, and so I was able to go and measure them, scale them down. I didn't know if they were going to print because they were so small. And I got some of those examples up here. In the thickness, I've got it down to where it's 20 thousandths thick on the webbing, the whole 16 thou, and on the outside, it's a minimum of 11 thousandths. That's from the hole to the edge of the material. If it was any tighter, I don't think it would have printed, but fortunately I got lucky and it printed for me and it worked pretty good. Yes, sir.
You could print that 3D blower with rotors inside that move.
You want me to change the car now? You could, yeah.
Yeah, oh yeah.
Oh yeah, you could draw. I've thought about doing that just to see how it would print and
Your
how.
fire bottle hollow too.
Yeah.
Oh, that'll be another year.
Well, it'll be the next year for you, Dano. No, but yeah, you're right. You could do, if you want to do a lot of internal stuff on, let's say even a block, you want to put the pistons and stuff, you could draw it all up and have all that detail. And just end up, at the end of the day, it'll cost you a little bit more because of the material, but if you want to add that, you can do it. So let's see. Okay, so here's another, this is a chassis. I just wanted to see if it would actually print, and this was based off of a Woody Gilmore 144-inch wheelbase front engine dragster chassis. And the print is actually, many of you probably know the name Roger Lee. I think he was one of the original guys that drew up this, and it's a drawing that I took, drew it up 1:1, and scaled it down to 16 scale. I printed it. I've got it over here just to see what it was. I made some mistakes as far as, and I'm going to do this, hopefully you guys can maybe see. You can kind of see how I can move this. When it actually was shipped to me, it got damaged, so it's not perfectly straight, and part of it was inexperience on my side. I should have put some extra supports for it. I would end up putting some things here just to stiffen the chassis so when they ship it, it doesn't get damaged, and you could cut the pieces out. And part of it, I just wanted to see, would it print this? Even though I want to actually build this in brass, I wanted to see, can I print it, and is it capable of doing it? So here's a couple more side views and top views of the chassis. And this was actually created with what I'm going to call a 3D sketch. Instead of doing things in the planes, I did everything in a 3D sketch, and then you come back. SolidWorks has what's called a weldment. So I was able to go in and pick my sketches and pick the different tubing sizes I needed, and it would actually just inlay the stuff. After everything was in, like this guy here, I'd come back and I would trim. It's got another feature that you trim it, because part of it, when it gets extruded, it comes in and and probably you don't need to do it with the 3D printing, but it's it's coming up. If you're wanting to do something and have dimensions that, hey, I'm gonna machine this and do the coping or the fish mouthing of having the tube seat up against the other tube perfectly, you can know that actual dimension off the CAD file. Now, here let me take a quick drink here. So I wanted to kind of go through, how do you export the parts to have them 3D printed? So you first, you need to save your 3D model out in a file format that the 3D printer can read. And this is touching back on, as far as using the most common file is an STL. And for those you may, hey, what is an STL? It's a stereolithography file, which is a file that is native to the stereolithographic CAD software created by 3D Systems. And this file format is supported by many other CAD programs and is widely known for rapid prototyping, which is the 3D printing, and for computer-aided manufacturing for the CAM programs. I know there's other file formats that can be exported, Parasolids, IGES, but I think there's another
most of the printers on the market have to have STL.
Yeah, I think that's probably the most common one. I know there's one other one, but the STLs is what I would say if you're gonna decide to do this. This is what I use all the time is the STLs, and it works out pretty good. And basically the STL, it's describing just the surface geometry of the three-dimensional object. And so here, I'm kind of going through, I want to show you as far as the steps is saving it as an STL. So here I've drawn up an injector hat. And just up in the file, there's a save as button, and you can come over here and it's got all these different file formats. I just picked the STL file. From there, hit the OK button. And what SolidWorks will do, it'll come in and it'll kind of analyze a little bit of the part. And you can actually take this and turn some resolutions higher or lower, and it'll actually make the file, it's building a bunch of different little small triangles. And depending on how coarse or fine you set it, determines, I guess, how big the file is. And I know Shapeways limits, I believe, the file size on how much you can upload or how big the file is able to be. If it's too big, it actually won't let you upload it to be able to print it. So you got to come back and kind of change that, or just see, some of it I've done it so they're a smaller file just so that I know that it'll make sure and print. And so here's, once you get the part, this is a little bit up off of Shapeways website here. You'll come in and they've got you'll create a little account or whatever, and it has a thing that's My Models. You can kind of see that in the background right here. And they'll end up going and you upload your file. It'll ask you in these boxes here, it's either going to be millimeters or inches, depending on what you draw in, or so it kind of knows. And then so once you select your part, it gives kind of a fake file path, and it'll go through and upload. It'll upload as you're uploading here, it's saying, hey, your file's uploading, you're kind of waiting. And so once things actually kind of start to upload, it'll come in and it'll give you some X, Y, Z components. It'll kind of give you the file size, and you got this little wheel over here that is kind of working its little magic until it actually uploads. So it'll actually show you an image here, and what it's got down here, there's all the different materials are down here. And so it'll actually, after it uploads, it goes through a process in here where it's actually analyzing the part, making sure it meets some of their minimum thicknesses, requirements to print stuff. And they've got some of the materials, they've got this, what it's like an X plus Y plus Z has got to be greater than a given value. And if it's too small, it won't print. And I found on some of I think the linkages, I can upload it, it can show me what it was, but it would say, hey, it's not going to print because it's too small. So one of the ways that I faked the printing process out, as far as I made kind of a little sprue. It's almost like a sprue from the model kits where I'm adding the little pieces, and I kind of, hey, it's bigger than what it's trying to print, and so hey, I can print something with little pieces, I can cut them off, and it actually printed for me on these little guys here. So the next step, depending on the type of materials, you may get some different errors because different materials require different thicknesses. Like this here, I think this may have been the white soft and nylon. And here what the program will do, it'll come up on this guy over here, you got these check marks saying this is good, this is good. Oh, we have an issue here. And what it's doing on this guy, you see the red and green, and what it's telling me here, the red is too thin. So you can do a thing where you automatically fix it, or knowing what the requirements are. In their materials page, you can actually see, hey, this is the minimum thickness that I need for just a surface, or I'm doing something that's a cylinder, like a pipe. It'll tell you kind of what that stuff is on their website. And so you may have some issues printing, or you can print it and see how it goes. Now, this guy here, I can't remember exactly what it was, but I think I just chose some other material that had an issue, and it's telling me, hey, the bounding box, this thing is too small for what it was. And it may have been one of the materials, besides the frosted ultra detail, the white soft nylon, they got some detailed plastic. They got, I think, PLA, which is, I can't remember exactly what it's like. It's kind of like an ABS, but it's a little bit harder than ABS. But you can actually print brass, steel, gold, platinum, if you want to spend the money. I think there may have been titanium. I think the blower, for giggles, I was looking at it, and I think it was like $6,000 to print the blower in platinum. Who's got that type of money? It'd be kind of cool if you win the lotto just to do it, but it would kind of, I'd like to see the quality of this stuff, but it's kind of amazing to me that you can print metals and everything else. Yes, Jim?
Getting back to your chassis there, it's plastic.
Yeah.
At this point, you could take that to a company that does jewelry foundry work, okay? And they would invent that in the slurry and then burn out the plastic and then inject that metal into it.
They could, yeah. Well, they also do, Shapeways does it's a castable wax or something, or you can mold it and then like heat it and it'll,
Lost investment.
yeah, lost investment. Yes, Greg?
How that, say they fix that, the green whatever at, I mean, they fix it on Shapeways.
You can click a thing to fix it, and they can, the thing is, I've never done the fix on Shapeways because I don't know. I'd rather do it because then I know what exact thickness or whatever it is that I need to go. They may just make it say, hey, what if they decide to fix it and you got this step up that comes, and
You'd rather see
I'd rather see it in my own file and fix the file myself personally. Then I know I've got a good model, and anytime, yeah, in the future you wouldn't have to worry about that again. So let's see, what's the next guy? So a little, okay.
On
You ready
the
to back up?
chassis, how about length, strength of the plastic? How do you determine, is it gonna sag, is it not gonna sag?
I guess that I didn't know what it would do.
Trial and error?
I was trial and error, yeah. Because I'll be honest, when I printed this, I think I was taking tubing. I could have left it as a solid rod, but I was going, okay, let me see the price, and let me see if I can take a little bit of material out just to save some money. And it'd probably be, tubing's probably a little bit stronger than rod when it comes down at the end of the day, but printing it may not make a difference for what we're doing, but depending on, I guess, the other components that are going on to it, how heavy stuff is, maybe that could affect it. Or you could do some stuff where if you wanted to actually print, let's say just like the back half and you have a front half that you're bringing together, because the frosted ultra detail, you're limited to, I can't remember if it's say 7 or it's got a bounding box. It's about 8 inches long. So if you had anything bigger, it's not going to print in that. So you have to go to the white soft nylon, which, in my opinion, it's not as a good material to use, but it depends on how clean and how detailed you want your material. But you could do it in 2 pieces, and then you could say pin it, have some sort of rod that comes in and glue the 2 pieces together. I don't know. Hopefully that answered a little bit of the question. Or
Pretty much just is experience.
it's some of, yeah, it's trial and error, I guess, for me. And I don't know how much that, maybe depending on what you add for, I would think your structure's like in a real car. If you have more structure here, it's going to be definitely stronger. But maybe this is, I don't know. I guess we can see. I mean, some of it's kind of flexible, you can see, but I know it's got pieces here that have actually broke from the shipping of it. But I guess it's more trial and error on some of it. Yeah, Paul.
I know that TDR, they did a 8-scale Koberna, they did a chassis, they did a hollow, and it sort of like a brass rod, and then
So they hollowed it so you can put a brass rod to keep it stiffer.
they found that they were just a or straight, it wasn't strong enough to support.
Okay, so maybe that would be a good thing as far as, depending, I guess I didn't consider that on a bigger scale. It's definitely may not be as strong, so as Paul mentioned, that Shapeways, they're recommending putting a brass rod or some sort of rod in there to stiffen the, or TDR, to stiffen up their chassis and stuff. I know there was another hand up over here, I believe.
Yeah, you could do a base for that frame, and have the base 3D with the chassis. And
Yeah.
then ship it or-
Oh yeah, you're right. Yeah, you could do something, but then again, depending on how thick and how big the base is, it may cost you twice, or I mean, if you're doing it solid, because I'll tell you, I drew
Well, do like 3 pieces, three or four.
3 spots to kind of reinforce
Yeah,
it.
act like a screw, basically.
Yeah. So I did another thing that, I'll get to this in, when he was talking about the base, it just made me think of, I did a tire for someone, and as far as, it was in the Frosted Ultra detail, the tire was probably about 4 inches in diameter, and I think once I made it a two-piece, I had a center piece, and I wish I would have shown a part of it, but I may have a picture on my phone if you guys want to see it. If I would have made the thing solid material, it was probably about $300 or $400. And at the tire, once I hollowed it out and made just a sleeve so it would cover the inside, it was about $65 to print. So just trying to show you how by changing the thicknesses and stuff, you can kind of get some stuff at a little bit cheaper cost instead of having a full solid piece, or maybe you're taking a tire, you can make this as a master, mold it, and you always have a good master, I guess, and resin's a little bit cheaper. So to touch on a little bit as far as the prepping the 3D printed parts, the process that I kind of used with the Frosted Ultra Detail and the Frosted Extreme, like I said, on occasion I'll do a strong flexible plastic, but most of the time I like the Frosted Ultra and Frosted Extremes. When I get my parts back from Shapeways, I will actually soak them in acetone for about 30 seconds, 20 to 30 seconds. It kind of comes back with a waxy material. So you need to make sure you clean it well so that the paint will stick. So once I go through the acetone little bath, I'll actually take them out and I'll wash them then with Dawn soap and a little warm water, scrub them down with a toothbrush, rinse them, and I'll typically repeat the Dawn washing. And then I'll go through and I'll use either, I'll spray some Tamiya paint or Automotive 2K Clear or whatever your favorite primer is. Because there is some surface, they're not going to be smooth like an injection molded part. And I don't know if a lot of people are expecting it just to be, hey, it's just like a model kit. And some people may see it and be like, well, I don't like this because I got to do some extra work. Sometimes maybe the 3D printing is not for everyone. It's just you got to do some body work, smooth it out. And you can see from, I've got one of the blowers here that's kind of the natural, how it came. I think I already wash it in acetone. I got one that's primered, and then you can take a look and see how the finished product is on my funny car, where you wouldn't really be able to tell that it was probably 3D printed at the end of the day. And but once you kind of go through, do the body work, you just do it like your normal stuff, and then it's ready to paint. And the smoother you get the product, the better it's going to look when it's done. So I think that's about all that I have. Any questions?
I want to get an idea on the price.
Price-wise?
Yeah, you send the file to Shapeways for that frame, for instance.
This
How
guy
much does that
here,
one cost?
I think he was about, it was somewhere around $20, 20 to 25, I think. It was about that.
That's
Maybe it was like 18 to 22, I don't remember.
Shipped to you.
That was just that price. The shipping, I think, was like $5 or $5.99. And as Jameson mentioned, normally when you upload your files, it'll go through and you place an order. It'll tell you, hey, thank you for the order, we're processing it. It's gonna go through and they're gonna do a check themselves where they kind of manually check the parts to make sure they're printable, even though it runs through and says, yes, it's okay, but they also run through and do their thing. And then it lets you know, hey, after they do their checks, your part's in processing, it's being made, and then it'll come back and say, okay, it's shipped. And how he's talking about, I'd say the lead time, where it's about a week, or it's getting better from them, because before it used to be like 2 weeks. It was a lot longer lead time. Now they've probably refined the process that will speed up. And I think the Frosted Ultra Detail, it's supposed to be maybe 6-7 days, I think, once it goes through. And then the Extreme, it may be a little bit longer, because I think they only have one machine, or I don't know, but I believe they don't print everything at Shapeways. They outsource a lot of stuff. So White Clouds, who is up here, up in Ogden, just about 30 miles north of here, I think has printed a lot of my stuff, even though I've uploaded it to Shapeways. So.
What's the license fee?
For SolidWorks? Software-wise, basic, like SolidWorks has, there's SolidWorks Standard, SolidWorks Premium, and Professional and Premium. Retail price, the standard's about $3,500, plus there's the maintenance fee that's probably about $1,200 to $1,500 a year, and it goes up. I had one of the companies I worked with we had gotten the professional, plus they got the simulation.
You're doing
package.
this through work?
This is
software
through,
work?
this is through work. And they ended up getting the simulation package, and it was about $14,000, but the simulation, you can go through some.
If you're a vet, you'll get a discount.
Yeah.
No, I'm serious.
Oh, he
There's
is,
all sorts of discount levels.
there's that, if you're a student, you can get a student version. Now, a couple things, I think, and you're gonna touch on Fusion, right?
Yeah.
I believe Lynn and I were talking, and I think you can get that software almost free. I don't know, I don't wanna say that, but I know, the main company that does SolidWorks is called Casala Systems. And they've got a free, it's a two-dimensional called Draft Site, which I don't know if many of you have heard of AutoCAD. It's kind of a two-dimensional thing, but you can download that for free and just, do some two-dimensional sketches. You won't be able to do the 3D stuff in that program, but you could draw templates, and I've done that before where I take something and draw it up, and I'll print it out, put it on a piece of plastic, brass, whatever, and cut my part out. So I mean, if you want to try something with some sketching, you can do that.
If one of your grandkids in college, you can get the student version free.
Right.
You can do, even I believe being a veteran, you need, is it
Yeah.
discounted price or is it free?
It's free.
Free.
I'm not sure, but they're, as they do for students, you can get really steep discounts, if not for free, and the same thing for vets.
Yeah.
A lot of times for the students, it'll be like a 1-year license.
One, yeah.
It's a one-year
Another one
license.
that I believe that,
It's a one-year license, you have to renew it every year.
okay,
So you gotta be a student.
that's SolidWorks. Now I know they've got another one called Google SketchUp that I believe is free. It's not as extensive as SolidWorks, but it'll get you some basics of drawing. Hey, let me get the lunch out of my back.
I was just gonna say, the other way to go about some of that is actually enroll in one of the community colleges has
Yeah.
SolidWorks classes, and you actually learn how to begin the program.
So yeah, he just mentioned there's junior colleges, community colleges that you can take some SolidWorks courses that'll go through and show you how to use it.
The 1/8 scale car that's on the table downstairs, the white super modified, over half the parts in that car are 3D printed.
Well, there's another example of parts that have been used down there. One more. I know Lynn's wanting to get up here, so.
Chris, when you're cleaning the parts of the acetone, when you finish cleaning them, can you still smell the smell, or can you lose that smell when it's clean?
You're talking with the
The acetone.
the actual ultrafrost. I just go by the way it looks. I mean, because I guess I've done it a couple times. I just know. One of the times I think I left in there too long, and it kind of did something funky, and it got real soft on me. So I decided not to really soak it for quite a while. I think I left it in for like a half hour, 45 minutes, because I didn't know any better. And you learn the hard way sometimes.
Have you ever done the acetone with the fume process?
Perfume.
Fume? No?
I'm not familiar with that.
That works on ABS.
Oh, to smooth it out.
Yeah.
Right.
Yeah, okay, no, that, I've heard that as far as the ABS, it actually helps smooth it. And I believe that there's I don't know if it's from Reynolds, someone has some stuff called Smooth On. I believe you can brush it on.
It's from Smooth On.
So you can brush it on the 3D printed parts. It's supposed to help smooth it out, but.
All I've ever done on mine is clean them with just denatured alcohol. Just stick them in a
Okay.
little thing, get them wet, then brush them off like you said with like.
I've never tried. Someone told me the acetone, I just use that. That's work because it's kind of a waxy material.
I know this sounds dumb from the paint guy, but I always hate to get near chemicals.
Well, go figure.
One
I'll also be up here as far as to ask more. I'll be here for more questions. But I know Lynn's needing to do his little thing because we're limited on our time, I guess, right? Or,
Chris, one quick question, extreme and possible, do you like, is there much of a difference?
the extreme, in my opinion, you're getting the resolution is tighter. It's better. So basically, it's the quality. So I got a couple things here I can show you with that's been some small lettering that I actually on my blower says Mooneyham. I didn't know if it would print. I tried it and you can actually read it. And it's probably about 10 thousandths thick, I think, when it printed. Lynn? Or Matt? Someone? I don't know who's next.
Yeah, thanks. Wow. Awesome. Awesome. Killer. No, I loved it. I'm a geek.
So next up, we're going to have Matt Wells, and what are you talking about again?
I'm going to give an overview of the industry, how it started, how Scale Motorsport got involved with it, and what you can expect to see in the not too distant future, and what you can expect not to see in the not too distant future. 3D printing patents were first filed in the 1970s, so this is not a new technology. In the 1980s, we started to see machines that were doing what was referred to as rapid prototyping. Perhaps most of you have heard that reference before. And rapid prototyping was a machine that you would use CAD software to develop the parts, and then the rapid prototyping machine would be used to print prototypes for viewing and changing details. It was a quick, easy way to evaluate designs and to see the effectiveness of how parts may fit together or work together, and it's a quick, easy way to make changes using the CAD software. Around the year 2000, Scale Motorsport started to use CAD software in developing all of our 3D printed parts. Some of you may be familiar with the Porsche 935 Super Detail Kit we did, released in 2001. All of those parts were developed using CAD software, and we did rapid prototyping for many of the parts that were in that kit. And in 2006, we released our Shelby Cobra Daytona Coupe. That entire kit was all CAD developed. It was all rapid prototyped, and the final master prints were all done using rapid prototyping. The parts that we made, all those parts that were printed, we used for masters, and all the parts in the kit are resin casted. So we've been actively using this type of technology for about 12, 13 years now. And what we wanted to do was to really come out with 3D printed parts. In other words, we didn't want to make the parts and use them for resin casting. We wanted to develop parts and sell 3D printed parts. What we found in our market research was that all of you guys are excited about using 3D parts, building with 3D parts, but most of you don't want to do the 3D printing yourselves. And the technology really isn't at a point where you can do that yourself. So a service like Shapeways comes in, and it's very beneficial. You'll take a look at Chris's parts here. They're absolutely fabulous. I think, are all of them done by Shapeways? Just a little side note, Shapeways doesn't print anything anymore. So when you go to Shapeways' site and you pick a part to print, they're not printing it anymore, and they're not shipping it anymore. You're actually doing business with a company called White Clouds, which is right here in Ogden, Utah. And White Clouds was here 2 years ago. They did a presentation, and I was so impressed with their presentation and their approach to printing parts. I made a separate trip out here a few months after that to go visit their facility. And if you ever have the time to go visit White Clouds, I strongly suggest you do. It's like walking onto the deck of a Starship Enterprise. You walk into the facility, it's about 60,000 square feet, and it got rows and rows and rows of 3D printers. Now these are not your $500 or $1,000 or even $10,000 printers. We're talking about printers that range from $80,000 to $250,000 a piece. And this is a manufacturing facility, and the place is so quiet that the only thing you hear are people talking and the casters on the chairs rolling around on the floor. You see lights flashing and things moving, but you can almost hear a pin drop. It's so quiet. It's really quite an experience. So if you get a chance to go visit, perhaps the next time we have the GSL 2 years from now, they're about 40 miles from here. Let me tell you, it's worth the trip. So we were so impressed with what White Clouds was doing, we decided that we wanted to develop our own wheel line. We figured that, wheels are probably the most important part or the first choice that guys make when they decide what subject they want to build. Wheels are probably the most important component. So we worked with White Clouds to develop a wheel line that would be 3D printed. So the parts that you get from us are actual 3D printed parts, but we wanted to enhance them more than just buying the 3D parts. So in our wheel kits, you get turned aluminum components such as the trim rings, the center hubs, and then you get photo etch details to enhance the wheel buildups even further. And they're for 1/24th and 1/25th scale tires. The product line's been very, very successful. We'll have it here tomorrow at our tables, and you'll also see the full wheels built up on several different cars that we'll have on display. Now, all of this 3D printing stuff that we've been talking about today, including Chris's great presentation, is what's referred to as additive manufacturing. All the machines that are used to print those parts, they're actually taking a spool, if you will, or a thread of plastic material, and they're heating it up and they're extruding it through a nozzle, and that nozzle is depositing the resin, whatever material it is, and Chris had mentioned there's several different materials.
I believe that this is it's like a powder, and they go through with lasers, but there is the
Yeah.
SLS.
the SLS.
Yeah, that's slightly different. Actually, all of those technologies now are old hat. Okay, so as great as this stuff is, this is getting to be old technology already. There's 2 new technologies out now, and you can view them on the internet. One is from a company called Carbon 3D, and the other company is called EnvisionTech. Now, you won't know what EnvisionTech is, but you are familiar with what they do. If you ever watch TV and you see a commercial on TV for Invisalign, those teeth straightening things, those clear stuff, all that's 3D printed. And it's all 3D printed using EnvisionTech machines. And that technology is called DLP, digital light projection. And what that is it essentially takes, I'll simplify it, a light projector, and it takes an image that's created in CAD, exactly the way Chris had shown you in his drawings, and they take that image and they project it through a chemical soup. And you literally, the part is, you gotta go visit the website, it's kind of difficult to explain. The part literally gets lifted out of a liquid bath. There's no additive,
It's way cool.
there are no layers, there's nothing. It just gets lifted out of the bath. If you go to their websites, it's Carbon 3D or EnvisionTech, you'll be able to see how this stuff works. The EnvisionTech product is called digital light projection, and the Carbon 3D product is called CLIP. I don't remember exactly what CLIP stands for, but it's also a light emitting projection system. This is pretty exciting stuff. That's the next phase of what 3D printing is going to be about. It's a very, very exciting field. It's great to see what Chris has done and the parts he's brought. And I hope you'll stop by our tables tomorrow and see what we've got. And I really appreciate being here. And if you got any questions, let me know. That's about it.
Where's White Cloud at?
They're in Ogden, Utah, about 40 miles from here.
Okay. North?
What's that?
North?
No, it's 35 minutes from here.
35, okay, yeah.
Would you call them up or something, or how do you get, how do you?
Yeah, you call them up, you can talk, the gentleman that was here last year, his name was Kerry Edwards, Kerry Parker, excuse me. And asked to call there, tell Kerry that you attended the GSL. He'll remember his visit from last year, his presentation, and I'm sure that they'll be able to arrange a quick tour for you. It'll blow your mind. It's miraculous to see that. If you want to see the future now, that's where you need to go. It's great, it really is. Thanks.
All right, thank you. All right, and up next, last but not least, is Lynn Koberna. He's going to be talking about Fusion 360.
Thank you, Jameston. We're really tight on time here. My presentation's going to be about 10 to 15 minutes. Are you guys okay with that? Sure. You want to stand up and stretch for a sec? Yes, no? Okay. I just want to say amen to everything these three gentlemen have just said. You have really got some good education here. These guys know what they're doing. And so I just want to thank them for being part of our 3D modeling and 3D printing presentation today. And grateful they accepted my request to partner with us. What I'm going to talk about today is car body design, also known in the industry as surface development. And the company I'm going to talk about is Autodesk. Autodesk is also a major CAD company that produces software for engineering, civil, structural, aeronautic, a lot of different fields. And they also do a lot of arts programming. They do 3ds Studio Max, if you've heard of that software. That's a major 3D modeling software for gaming, and they do Maya. Yes?
Don't they do AutoCAD?
Yes, they do AutoCAD.
Right.
That was their premier product. They have really expanded. They run a software called Alias, which is what car body designers in the industry use to design the surfaces and shapes of automobiles. The product that I'm going to talk about today is Fusion 360. It's Autodesk Fusion 360, and you go to Autodesk, download it free. And you have to earn $100,000 a year in order to actually have to pay for the software. So they have a hobbyist version. It's the full-blown version. It should do just about everything that SolidWorks do, plus a few other things. Yes? What? Mac and PC. Yes.
So 100,000 is that or adjusted gross income?
Well, I think it's.
Well, you're gonna have to wait for the tax reform
I think
bill.
it's revenue.
And then
I
we'll
think it's
figure it out,
revenue.
you know.
Is it based on the honor system?
Yeah, pretty much.
Okay.
Pretty much. So to run CAD and do this, you need an 8th grade education. Okay, you need to remember 8th grade geometry, XYZ coordinates, and basic shapes like spheres and arcs and pyramids and triangles, lines and planes. That's what is the basis behind this. Autodesk bought some technology a few years ago called T-splines, and they are the sole licensor of T-splines. You can't any other application that uses T-splines has to have an Autodesk license to do that. Now they're starting to limit those licenses, so they're becoming this exclusive provider. Now what's of value to us in using T-splines is that we can get very clean, precise, smooth curvatures and shapes in automotive design. The program Alias is the one that they also use the T-splines software in that, or technology. So what you saw in SolidWorks you can do with Fusion for the most part, but then I don't know if SolidWorks has a sculpt environment. Does it?
I don't know, I'm not sure on that.
Okay, Autodesk Fusion 360 has a sculpt environment. And what the sculpt environment is that you actually create things that simulate clay. So you remember this morning I talked about the scanning software, and creating a mesh, and then you convert that mesh. AutoCAD or Autodesk Fusion 360 will take those mesh files and convert them into T-spline files so that you can actually manipulate the bodies. Write this down so you can go online and watch these tutorials, okay? Go to Autodesk Design Academy on YouTube. And there's a playlist called design visualization for industrial designers. Okay? And if you follow that, there's like 13 tutorials that walk through how you design the surface bodies for automobiles. So I'm going to show you some finished images. If you want to show those 3 images.
Just.
This is what the finished product looks like.
What the?
While we're waiting for that, can you say that name of that playlist again?
The playlist is Design Visualization for Industrial Designers. Industrial designers are product designers. They do the aesthetics combined with the engineering and the manufacturing to create products. So this is, where's my, this is Autodesk Fusion 360. This is their interface. And right here is what they call the browser. And this is basically your parts list. And you can visually turn on and off the parts to see what your image is. Now the lines that you see here are T-splines. You can see where they intersect in a T, and you can manipulate, there's little handles, you can manipulate those to change the shape. There's a feature here called where you can actually go to 3D printing facilities, service bureaus, and estimate the cost of your part. There's over 150 different service bureaus that you can access, and so you can compare parts and materials right from Fusion 360. You don't have to go to the service bureau to get your estimate. So let's go to the next slide. This was a car body, and then with Fusion you can render it. And this is what a rendering is of that same car body. And then go to the next slide, please. And here it is in a full photo rendered image.